Alright class, this was your crazy take-home problem. You ready for this? Alright, so what was the carbon chain? The longest number of carbon atoms in a row. And remember, we said that the carbon chain is the longest number of carbon atoms in a row. And you're probably going to say, okay, it's probably this one. Because every problem we've done so far, it was pretty much this straight chain one. And that would be 1, 2, 3, 4, 5, 6, 7. But that's not it. That's not it. Because remember, you have to do the longest number of carbon atoms in a row. How about I do this? So I have to be a little more careful. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can I do that? Why not? Do it in a row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 carbons in a row. So I know everything we did last time with the straight chain down here, the backbone seemed to be the straight chain, but that's not usually as obvious sometimes. You just have to keep counting because it has to be the longest number of carbon chain, number of carbon atoms connected together in a row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In this case, it's 10 carbon. And that's okay. That would be decane. Okay, so if that's my carbon chain, which I know it looks crazy, now what are my substituents? This one, and this one. How would I name it? Do I name it number, left or right? Well, look at it. If I number from here, 1, 2, 3, 4, 5, 6. 4, 5, 6 will be my substituent. If I number from the other way, 1, 2, 3, 4, 5, 6, 7 will be the substituent. No, you want the lowest number possible, so I'm numbering it from the left. So far, so good? Okay, so we know that the carbon chain is 10, is decane. Now, I have substituent on carbon 4, on carbon 5, and on carbon 6. You agree? On carbon 4, it has only one carbon, so is methyl. On carbon 5, what kind of substituent I have? Is an ethyl, because there's 2 carbon. On carbon 6, is only 1 carbon attached to it on the branch. Again, we can look at the branch. The branch has only 1 carbon, so it's methyl. Now, I have 2 of the same type of substituent. They both are methyl. If you do that, you combine them and you use prefixes. So this is 4,6-dimethyl. Dimethyl because I have 2 of the methyl, right? Now, the last thing to do, we did that last time a lot, to put it all together, you put the substituent first and then you put the carbon, the parent, the carbon chain. Alphabetical. Ethyl, E has to be first. So 5-ethyl, 4,6-dimethyl decane. And you put a dash between a number and a letter. And ethyl and methyl. Okay? You exclude the prefixes when you are doing alphabetical. Yeah? This was a big one. If you got this down, we're in really good shape. Nice job. If you didn't, that's okay. This organic chemistry just takes seeing the molecules and then realizing what you got. Now, let's move on to the next part, which is naming cyclo alkanes with substituents. So naming cycloalkane with substituents. We named cycloalkanes before, so let's see what happens if they have the substituents. Well, first of all, name this for me. You know how to do it. How many carbons is in a ring right now? 1, 2, 3, 4, 5, right? So this would be cyclopentane, right? Because 5 carbons is cyclopentane. Not bad. Doesn't have any substituents. Life is good. Now, what if I give you this? Okay. Again, 1, 2, 3, 4, 5. 5 carbon. Again, is cyclopentane. Now, when you have a substituent, you have to number it. So basically right now the ring would be your longest carbon chain, right? This would be your parent carbon chain, your parent group. Now you have to number it. You have to number it when you have a substituent. And again, you number it in a way to give the substituent the lowest number possible. So if I want to number it, I number this carbon 1. And after that, it doesn't matter which way I go. 1, 2, 3, 4, 5, or you can go the other way. It will be the same thing. So what I would have on carbon 1, what do I have? This is my substituents. What do I have on carbon 1? I have a methyl. So on carbon 1, I have a methyl, 1-methyl cyclopentane. Right? Not bad. Now, in this case, you can omit 1. Because if I say methyl cyclopentane, there's only one substituent. It doesn't matter which carbon you put it on. That carbon will be number 1. So you could omit 1 if you like. They usually omit 1 because, again, it doesn't matter if I say methyl cyclopentane. You would just put the methyl on one of the carbons. Yeah? Okay. Now, let's do more practice problem to make sure you get this down. Here's the next one. It's hard to draw this. This is not a square. It looks like a square, but it's not. What type of ring is this? 1, 2, 3, 4. So it's a cyclobutane, right? Because I have 1, 2, 3, 4. So it's a cyclobutane. It has a substituent, which means I need to number it. Substituent here, substituent here. Okay? So number it in a way to give the substituent the lowest number possible. I can do 1, 2 or 1, 2, wouldn't matter. 1, 2, 3, 4. Okay? So what would be the name? The same as before. They both are chloro, right? So 1, 2, dichlorocyclobutane. Nothing has changed. You combine the same type of the substituent. 1, 2, dichlorocyclobutane. Yeah? Okay. Nice job. Let's do one more. So this is a little trickier. I think you can do this. You can definitely do this. Okay. Yeah? Do this for me right now. So, probably what you did, you go 1, 2, 3, 4, 5, 6 carbon. If I have 6 carbon, that would be cyclohexane. That's good. Okay. I have a substituent here, and I have a substituent over there. Okay. I have a bromo, and I have a methyl. Okay. Now, how am I going to number it? Number it in a way to get the lowest number possible for the substituent. How would I number this? Would you do this? 1, 2, 3, 4, 5, 6. Okay. Let's name this based on that. So, alphabetical 4 bromo, 1 methyl, okay, cyclohexane. You agree? Because again, this is bromo and this is methyl. Okay, that's interesting. Now, sometimes if you're not sure about naming, I usually do both way. I number it both way and then I decide. So some of you guys might have gone, what if we start from here? Some of you guys might have said 1, 2, 3, 4, 5, 6, right? Can you do that? If I do that, what would I get for that? Let me see. Then if I do that, then I would get what? Help me out. Then it would be, this is my bromo, and this is my methyl, right? So then I would get 1 bromo, 4 methyl, you agree? Cyclohexane. Which one is right? Remember, we said we numbered the carbon chain in a way that the substituent get the lowest number possible. Okay? 4, 1, 1, 4. The substituent have exactly the same number. So which one is correct? Which one is correct? Okay. One is more correct than the other one. And the one that is more correct is this one. Okay, so when you're in this situation, that doesn't matter how you number it, the substituents will be numbered the same way. For example, here 4, 1, 1, 4. Then you go alphabetical because bromo is B, so bromo has to be the 1. So you go alphabetical. The one that has a lower letter, that would have to be the lower number. Okay, that one would have to be the lower number. So far, so good. Okay, that would be alphabetical. Then that one would be the lower number. Okay, so far, so good. So in that case, let's do one more practice problem to make sure you really understand this. Let me do it in blue. Okay, hopefully that made sense. Okay, pause me and do this problem. Now that you're on pause me, 1, 2, 3, 4, 5, right? There are 5. So 5 would be what? Cyclopentane. So 5 is cyclopentane. Now, how are you going to number it? You number it in a way to get the substituent the lowest number possible, right? Okay. You can go 1, 2, 3, 4, 5. Do you agree? If you do that, what do you get? And again, the substituent is this one, and this one, right? This is bromo. This is methyl. And this is methyl. So if I do that, what I'm getting 1 bromo, okay? 2, 3 dimethyl cyclopentane. Now, what if, just for fun, I number it from the other way? Because I would get the same number. What if I go 1, 2, 3, 4, 5? If that's the case, again, in alphabetical, it would be 3 bromo, 1, 2 dimethyl cyclopentane. When you're not sure, do both ways. So this is again one of those situations. I have 1, 2, 3. I have 1, 2, 3. They're exactly the same number. It doesn't matter which side. If I number it from here or from here, they will have the same number. Which one is correct? Hopefully, but you know this time which one is correct. Which one is correct? This one is more correct. Why? Because again, bromo, you have to go alphabetical. Bromo B comes before methyl, and you want the one that has a lower letter that comes sooner on in the alphabet. You would have the lower number. You would have the lower number. You would have to go alphabetical. All right, beautiful. I know these are hard stuff, but you guys are doing so well. We're almost done with naming. So we're done with alkane. Now we're gonna go to alkene and alkyne, but don't get freaked out. They're pretty much the same with a very, very small difference. So remember, alkene have double bond, alkyne have triple bond. They are so much more interesting than alkane. Alkane are just good for fuel. Alkene and alkyne are more reactive. They can do so much more because of that double bond and triple bond. Now let's go over the naming for these guys. So they are so much more interesting than alkane. Once you know the alkane, then everything else is pretty much the same. So for the naming, is same as naming alkane. So you already done the hard part. There is one exception. There is one exception, okay? Here's the one exception. You number the carbon chain. Remember before we numbered the carbon chain to give the substituent the lowest number possible? That's not the case anymore, which makes it so much easier. You number the carbon chain so that the double bond or the triple bond can have the lowest number possible. So now it actually got a little bit easier. So let's name this one together. The same as before. What is my carbon chain? What's the longest number of carbon atoms in a row? Hopefully you go, that is super easy. Is this one right here, yeah? 1, 2, 3, 4, 5. So if you have 5, you have pentane, right? Except now I have a double bond. So it's not pentane. What is that? It's pentene. Isn't that cute? That's very cute. Okay. Now, you are going to number the carbon chain so that double bond will get the lowest number possible. So I don't care that the substituent is over here. I'm not going to go 1, 2, 3, 4, 5. I care about the double bond. So I go 1, 2, 3, 4, 5. That's the only difference. Okay. So to put it all together, on carbon 4, what do you have? You have a methyl, right? So 4-methyl. Now, where is the location of double bond? Starts on carbon 2, right? So 2-pentene is pentene because it has a double bond, and it has a 2 because that's the location of the double bond. Starts from the 2. Starts from the 2. Not bad, right? Starts from the 2. Okay. Now, ready to do one more? Okay. Ready to do one more. My bonding will are not right on the next one, but I want to just get this out of the way so you learn the naming. But just keep in mind my bond angles are not really good. It's not the 180 it should be. Okay, name this one for me. You know how to do it. What is the longest carbon chain? The longest carbon chain would be this guy over here, right? That's my longest carbon chain. Okay, well, how many carbon? 1, 2, 3, 4, 5, 6, 7. So 7 is heptane, except you have a triple bond. So what is it going to become? What is it going to become? Heptyne. Heptyne. Nice job. How I'm going to number it? I'm numbering it in a way that a triple bond would get the lowest number possible. Here it would be 1, 2, 3, 4. Here would be 1, 2, 3. So I'm going to go from the 3. So it will be 1, 2, 3, 4, 5, 6, 7. So carbon 3, that's where my triple bond starts. So 3-heptyne is how it's going to end. Does it have any substituent? Yep. It has a methyl on carbon 2. So I have 2-methyl-3-heptyne. Again, you put a dash every time you have a numbered letter, you put a dash. Beautiful. Now, here's what I want you to do. That's it. That's as hard as it gets for double bond and triple bond. I want you to count and actually put the number of hydrogen on this one over here. Count the number of hydrogen. So let's do it together. Here I would get 3 hydrogen. Here again, because again carbon needs 4 bonds, 3 hydrogen. Here it has 1, 2, 3 already. It's just gonna get 1 hydrogen. This carbon over here, 1, 2, 3, 4. No hydrogen. This carbon over here, 1, 2, 3, 4, right? It already has enough, nothing at all. Here it has 2 bonds, 2 more, 2 bonds, 2 more, 1 bond, and 3 hydrogen. Okay. Now count the number of carbon for me. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 hydrogen. So I said 8 carbon. And then how many hydrogen? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And 14 hydrogen. What just happened? If this was alkane and no triple bond, how many hydrogen would it have? Number of carbon times 2 plus 2. 8 times, so remember, we had number of carbon times 2 plus 2, which is what? 8 times 2 plus 2, that would be 18. If you had, that would be the number of hydrogen, right? Except what I said before, I said every ring that you have, you subtract 2 hydrogen. If you have a double bond, for every double bond, you subtract 2 hydrogen. For every triple bond, you subtract 4 hydrogen. Because instead of the hydrogen, now you have carbon-carbon bonded. Does this make sense? Yeah. This one, if it was all single bond, it would have 18. But it had a triple bond. If you subtracted from 4, that would be 14. And that's what I get over here. That's what I get over here. That's kind of cool, right? So remember, this is the number of carbon. Every ring, you lost 2 hydrogen. Every double bond, you lost 2 hydrogen. Every triple bond, you lose 4 hydrogen. Beautiful. Very nice job. So let's go back to this one. I can read with the 4-methyl-2-pentene. 1, 2, 3, 4, 5. 4-methyl-2-pentene. Okay. Let's look at number of carbon and hydrogen. 1, 2, 3, 4, 5, 6. 6 carbon. Now, based on the rule that I just showed you, 6 times 2 plus 2 is 14. For each double bond, I subtract 2, so I should have 12 hydrogen. Let's see if that's what we see. 1, 2, 3 hydrogen over here, right? Here I only have 1 hydrogen because 1, 2, 3. 1, 2, 3. I only have 1 hydrogen because carbon does not need more than 4 bonds. 3 over here, 3 over here, 1 over here. Again, 1, 2, 3. One more. Let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It matched up. It matched up. So remember this. Okay? Remember this for me. This is a really good rule. Number of carbon times 2 plus 2 tells you the number of hydrogen. But then you subtract 2 for every ring, 2 for every double bond, and 4 for every triple bond to figure it out. Okay. Beautiful. Nice job. There's one more thing I want to go over, which is really, really fun. Functional group. Beside that, we are done with naming.